Hi, I'm Michał from Forlens, and today I want to talk about our solution that is designed to detect supply chain attacks, exploits, and unknown malware. Current security problems originate from trust. Companies trust software vendors, and this relationship is abused through supply chain attacks. Security software, to improve performance and reduce false alerts, trusts digitally signed applications, which leads to missed detections. And of course, there is still room for generic malware that uses novel evasion techniques to avoid being detected. Let's zoom into supply chain attacks. There are multiple ways attackers can use to get into the software vendor and plant malicious code. They can go after software used for development, developers and their computers, source code repositories, or just the final step where application is packaged and signed before being distributed to customers. In any case, the result is the same. Application or its update is downloaded from correct servers, has correct signature, but at the same time contains malware. If we look now at the security on the customer side, we have all the mainstream security products that are great at detecting threats that are already known or those that look similar to them. Their important element is the reputation system that assigns a good, bad, unknown score. The problem here is that the reputation needs time to build up and be accurate. So a new domain created for an attack will be unknown to them for quite some time. As a result, they generate a lot of events, out of which most require manual inspection and a dedicated team of experts that can decide if given event is worth any further investigation. So it takes weeks or sometimes months, like in the case of SolarWinds, before the malicious activity gets detected. We also have a new generation of supply chain security. It focuses on protecting software vendors from releasing malicious or vulnerable code. It checks if an application does not contain components with known vulnerabilities, and it generates software bill of materials, which shows which building blocks are used in the final product. The problem is that software bill of materials carries no information about network communications that the software will be using. What they also can't detect are vulnerabilities that exist but are not yet publicly known. In reality, the supply chain, as the name suggests, is a chain. The final application that is being distributed depends on third-party components, and they also can depend on other components and so on. Because of that, we end up with incomplete security on both ends, software vendor and final customer. An application usually needs to communicate with only a few servers. It might need one server to check for updates, one to fetch data, and one to send some telemetry. What if, because of supply chain attack or an exploit, there is malware running as a part of the original application? In most cases, that malware will initiate communication back to the attackers to report that it's up and running, to receive instructions what to do next, to exfiltrate data, and so on. From the point of view of security products, connections are initiated by a trusted signed software. Vendor domains are known, so will have a positive reputation. But in case of lesser known or new domains, the verdict will be inconclusive, and that allows the malicious connection to go through without any alerts being raised. Our solution provides a comprehensive allow list, constantly updated and managed by our experts. We apply zero trust approach, so the fact that an application is signed is not treated as a guarantee that it will never misbehave. Our allow list is designed in a smart, manageable way that allows us to aggregate expected connections, for example, by vendors. We also take into consideration additional information like how the application was started or by whom. This way, we can provide a very low amount of high-quality alerts, reducing the information overload of security teams and improving their mean time to acknowledge and respond. Information about allowed communication is also stored. giving insights into software vendors and applications being used across the company. Let's take a quick look at some of our features. Dashboard provides a general overview of recent alerts, endpoint status, and system updates. Then we have hi-fi alerts. Anything that shows up here requires investigation and is analyzed by us, but also can be inspected by your security team if you choose to. Lo-fi alerts are generated by chatty applications. They don't require immediate attention and can also be configured to be ignored. In this case, we see some links clicked in PDF documents. Domains that are used often by the company can be added to the local allow list. And then unknown domains popping up here can point at, for example, phishing attempts. Connections contain all the traffic that was allowed so far by the system. They provide overview of applications, their versions, and who is using them. Vendor list is another part of our inventory insights. It aggregates software vendors that are in use across the company. Now let's execute some malicious applications. Here we have an older version of VLC that recently is very popular among some threat actors. This version is vulnerable to DLL sideloading. It means that if the executable is placed together with a library that has correct file name, it will load and execute it, no questions asked. It will fail at some point because other vital parts of the application are missing, but the malicious code from the library will execute. From the point of view of security software, the malicious code is executing inside trusted application with great reputation, so there is a high chance it won't be noticed. In this case, the library is made by us and its malicious activity is limited to creating a text file and connecting to a benign domain, but not a domain that VLC would normally talk to. In real-world scenario, the library connects back to the attackers to fetch and execute more malware. Now let's also install the Trojanized version of COM100 Communicator. This is a real file that is a result of a supply chain attack that happened in 2022. The malicious code embedded inside starts to communicate with attackers right after the installation is complete. And the domain that is used for the connection is not normal for this application, so it immediately generates an alert. If we look now at alerts table, we see both unexpected connections made by our applications. We can also dig into more details, like the file metadata or who and when executed it. Thank you for watching. If you're interested in learning more, you can find us at forlens.com or contact us at the email below.